Okay, greetings class and welcome to lesson 4, INT1110. In this discussion we are going to talk about IPv4 and IPv6. I want to first congratulate you on making it to lesson 4 and continuing on in your educational goal and objective. Keep it up, you're doing great. You're almost at the end of this course. And so I'm going to go ahead and talk about the discussion IPv4 and IPv6. So if you'll join me on the screen, I'll be looking at the screen. We have IPv4. It is basically a set of numbers, and those numbers represent a 32-bit IP address. It's easy to tell the IPv4 because it's three numbers in 4 sets. Each one of these sets is called an octet because it's worth 8 bits. So this first 1, 2, 3 is the first octet. This is the second octet. This is the third octet. This is the fourth octet right here. Sorry about that highlight there. These 3 numbers here. And so 8 times 4 is 32, and that's how it gets the bit count, right? 32 bits. In IPv6, it's a 128-bit number. You can see it's much longer. It's much harder to remember what that is. So in this discussion, you are going to talk about a couple things, and we'll get into that in just a moment. I want to go ahead and explain a little bit more about how IP works. So here, this box represents like a router in your home. This cloud represents the internet. And this triangle represents your computer. So your router at home has what's called a public IP address, right? That means that IP address can be accessed by the internet, by the outside. Sometimes it's often called a WAN IP address if you're in a corporation and you're connected, interconnected. But this public IP address at your home gives you the ability to get out and talk to the things out on the internet, right? And your router will issue you an IP address, and this is typically a private IP address or inside, or your LAN IP address. Your LAN IP address, if this router was not there, could not go directly to the internet, right? It is for internal use only, whereas that router has a public, and that does that external communication. So you may have numerous devices inside of your house, right? Well, you might have, a TV, a computer, a phone, and they're all getting IP addresses, but they're going through that router, and that router is using that one IP address to communicate through to the internet. So when you see on those detective shows that someone's traced back to your internet address, they're not tracing your specific computer, but they're tracing your public IP address, right? They can get to where you are, so they know it's in your house. Maybe one of your devices accessed it, and they'll do some forensics investigations or whatnot. But that's how that whole system works. So when we talk about running out of IP addresses, we're talking about these public IP addresses, right? And you'll hear often that IPv4 only has about, I think, 4 billion or maybe less than 4 billion IP addresses that can be used. Well, these are only those public IP addresses. They're not your refrigerator, your phones inside of your LAN. All those aren't counted towards those public IP addresses. So what happens is an organization called IANA, which is Internet Assigned Number Authority, sells those IP addresses to internet service providers like AT&T and Verizon, and then they will in turn sell you one to utilize your router, right? So you'll get a dynamic IP for your router. You're not staticking in it, and the difference is a dynamic is it automatically gets an IP address, whereas static is you put it in directly. So you're given that IP address by your internet service provider. They can keep record and trace it back to you at that particular time, and that's how the IP address scheme works. So what's happening is these 4 billion IP addresses, right, that are going to these public entities, these public routers, these public, a web server, right? Maybe in the internet you're going to a Google web server, right? The Google search, that's a server that has a public IP address because you're able to access that. That's beginning to run out, right? Those 4 billion are beginning to be used. What they did at first is they introduced a concept called subnetting, where you can take a larger number or a larger IP address and break it down into segments and then use those segments publicly instead of issuing blocks of 8 IP addresses or 16 or 24 at a time. That, you know, they broke it down by using subnetting. I won't go into detail on subnetting, but if you're interested in the network field of infrastructure and IT, it's certainly something that you must know. And so this discussion is saying that these IPv4 IP addresses may run out. So what's an advantage or disadvantage? Why is IPv6 created? And then going a little bit further is that there's private and public IP addresses. And you know, the IEEE recommends the following sites to use in your LAN environment. So you know, we won't really talk about that as much, about the breakdown of IPs, but in this discussion you're going to talk about a couple things. One is that you know, what's the advantage and disadvantage of IPv4 versus IPv6. I've named one of them. All right, more IP addresses to give out, right? Maybe you can look into your book in chapter 14 and look at maybe security. Which one's better, IPv4 or IPv6 for security? What about speed? Is IPv4 or IPv6 faster? Or which is easier to remember, IPv4 or IPv6? So in this discussion, and based on chapter 14, you'll look at IPv4 and IPv6 and determine you know, pros and cons to using each of them and why those were created. One more thing I want to go over, and that's just setting in a dynamic and static IP. I always type in ncpa.cpl. I missed the dot there. This is Windows 10 operating system that I'm using. When I type in ncpa.cpl, my network interfaces or my network connections come up. You can get there similarly by going to Control Panel, Network and Internet, Network Connections. You right-click on the live connection. Right now I'm wired, right? You can tell that that's connected. This is not. This is not. So I right-click and I go to Properties. And in these properties, I click on the IPv4 and click Properties, and I have a dynamic IP, right? So that means a server is automatically issuing me an IP address. I can static that in by typing in a number here, right? But it must match what private LAN range that I'm using, as we discussed. In this case, I'll just leave it as a public IP, or as a dynamic IP. This, similarly, you could do the same thing here for IPv6. I have that unchecked because I'm not using that at all. I can simply check it and set my static or dynamic IP there. So either you're giving it out from a DHCP server or you're setting it statically. Another thing you can do is command prompt. Command prompt, you can type in ipconfig/all, and you can see the IP address, right? So here I can see that I have an IP address here. I have a local link, which is IPv6 has a local link, and IPv4 has a local link. I'll explain that in just a moment. Here's my IP address for my computer. Here's the subnet mask, right? That we talked about breaking it down. Here's my router IP address. And basically, this is a dynamic, like I showed you on the NIC. So the last thing I want to talk about is the local loopback. So if the local loopback, or an IP address that's not issued, is 127.0.0.1 for IPv4, if I ping that, I do get a reply. That is myself. So I can always test to see if my network is good by pinging the local link. That local link says, yes, your network connection is operational, by getting those replies. So the 127.0.0.1 is not issued in IPv4. All right, folks, thanks. That's all. I hope you do great in the discussion boards. Make sure that you are reading chapter 14 for additional information, and you're referencing this because this is not common knowledge, so I expect references this week as well. Okay, thanks. Good luck.